You can see another example right here of a vertical tangent line. They've shown the graph right there. There's the tangent line, the blue tangent line that goes through it. Notice this is a vertical tangent line. So again, if you took the limit as h approaches 0 of the difference quotient, you would have gotten infinity or negative infinity of this graph at that point. So the limit technically doesn't exist, but it is a vertical tangent line. Okay. The derivative of a function. What's the derivative of a function? The derivative of a function is this. We call it f prime of x, and let me show you the notation. Here's f prime of x. That's what we call it, f prime of x, right? Is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. What is that? All we're saying is, to us, f prime of x, the derivative of f of x equals, and we're going to use our version of this, the limit as h approaches 0 of f of x plus h minus f of x all over h. And this, again, really important. This is the definition of a derivative. It is so important that you know this, because problems are going to say find the derivative using the definition of derivative. And anytime they want the definition of derivative, they want you to look at the limit as h approaches 0 of f of x plus h minus f of x all over h, the limit of that difference quotient. Okay? Again, conceptually, what's happening, you're finding the slope between two lines, bringing them closer and closer together to be the slope at one point. So, says you have now arrived at a crucial point in the study of calculus. The limit used to define the slope of a tangent line is used to define one of the two fundamental operations of calculus, differentiation. So the other one's anti-differentiation, or integrals, and we won't learn that till the end of the semester. So we are going to concentrate the next 3 tests just on derivatives. So it says, be sure you see the derivative of a function of x is also a function of x. This new function gives the slope of the tangent line of the graph of f at the point x f of x, provided the graph has a tangent line at this point. So what they're saying is, on the last one, when we did the limit process, we got 2x. Notice it was a function of x, 2x, right? You give me the x value, I give you the slope of the tangent line for that x value. It says the derivative can also be used to determine the instantaneous rate of change, because that's all that slope is, right? Slope is just a rate of change between 2 points. So the rate of change at a single point would be called an instantaneous rate of change. Okay? And it says of the variable with respect to one another. So what we have right now, what we've got so far is, sorry, let me get away from the, there we go. First, we have the slope of the graph at a point, is the same thing as the slope of the tangent line which is the same thing as the derivative at a point. That last one should have been at a point too. Okay? Which is the same thing as the instantaneous rate of change at a point. All of those, any of those questions, if they say find the slope of the graph at a point, find the slope of the tangent line at a point, find the derivative at a point, or find the instantaneous rate of change at a point, to us that means find f prime of x, the derivative, and right now the only way we know how to do that is using the definition, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. All of those are the same thing. Every single one of those are the same thing. When you have derivatives, typically we use f prime of x, but that's not the only thing you're going to see. You could also see dy dx, which just means find the derivative of the function y with respect to x. You could also see y prime, or you could see d dx, and then they put the function there, or this d sub x of y. This is used in differential equations a lot. So all of this notation is used in random books at random places of time. You need to be comfortable with all of these. The prime notation or the d dx notation, be comfortable with those. All of those mean find the derivative.